Happy day, students. Welcome to San Academy Pallikaranai. I'm going to teach. I'm Lavanya ma'am. I'm going to teach mathematics for your class 10. Today we are going to learn chapter 1, real numbers. Before start the class, I'm going to give some activity. Welcome back. So let me ask one question. You know the variable numbers? Yes? Yeah. Because maths means you remember only numbers. So this question I'm going to ask you, what number do you get when you multiply all of the numbers on a telephone's number pad? You know what are the numbers will be there in the telephone number pad? Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0. Correct. Exactly. So when you multiply these all the numbers, what you'll get? For example, you multiply 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 0. What is the answer will be there? Yes, someone is saying correct, exactly, correct, super. 0. Yes. When you multiply any number with 0, the solution will be 0 only. Yes? Yes. So you know that one 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. When you multiply with any number with 0, you will get the product as a 0. Okay. Very good. Super. Let me start our class. We are going to learn in class 10, first chapter, mathematics, real numbers. What are the concepts you are going to learn at the end of this chapter? What is the learning objective and what is the learning outcomes you are going to learn? Learning outcomes you are going to get in this from this chapter. At the end of this chapter, you are going to get what is Euclid Division lemma, how to apply the fundamental theorem of arithmetic, how to find out the rational and irrational numbers, and also how to solve terminating and non-terminating decimal expansions. Very good. Shall we move on the first concept? Euclid division lemma? Yes. You know what is a real numbers? Yes. Can you able to recall what is a real number? Real number is a value that represents a quantity along a line. What is a quantity along a line? It is consists rational and irrational. Exactly. What is rational? Can anyone say? Yes, someone said that is in the form of P by Q. You learnt in your lower classes that is what is a natural number. What is a natural number? Exactly, super. Start from 1, 2, 3, 4. It ends with where? It's infinite number. You learned lakhs, 10 lakhs, millions, zillion, so many numbers you learned. Yes, but or 1, 2, 3 starts, it is called a natural numbers. And it is also denoted by n. Yes, and now if I add with natural number one more 0, then what will call that is called? Yeah, that is nothing but we are calling as a whole number. What is that? Whole number. Yes. The same thing if I start from 0, same thing if I start 0, 1, 2, 3, yes, and then 0 is a 0, 1 second, 0, 1, 2, 3, these are called whole numbers. The same way if I left hand side if I come, what will happen? What are these numbers are called? These numbers are called negative numbers. So combination of negative, positive and 0, what we'll call? That numbers only we are calling as a, what is that? Integers. Very good, super. Integers is denoted by Z, means Z. And if I add these integers some fractions, what is a fraction? Part of a whole. If I add with integers some fractions, then it is considered as a rational numbers. Yes, yes. So the which can be written in the form of P by Q, they are called as a rational numbers, which can be written in the form of P by Q. What is that called? Yes, exactly, rational numbers. Rational numbers, but you should remember one condition. What is that condition? It is form of P by Q. But someone is saying yes, correct. But Q is not equal to 0. Q is not equal to 0. Then it is called as a rational number. Yes, exactly is correct. F. Why? What happened? If I applied here Q equal to 0, what will happen? If I applied Q equal to 0, it becomes division by 0. So you learned division by 0 is not defined. Division by 0 is, what is that? Not defined. Yes, exactly, it's not defined. Yes, so you learned about that. Yes, very good, super. Now, this combination of rational and irrational numbers, we call it as a real numbers. The combination of rational and irrational numbers. What is it called irrational numbers? Yeah, you learned in 9th class. Irrational numbers are nothing but which are non-terminating, non-recurring decimals. Exactly, correct. Which are non-terminating, non-recurring decimals, call it as a irrational numbers. Yes, yes, very good. Now we'll see some examples of irrational numbers. Root 3 is an irrational number. Why? Because when I divide the root 3, square root of root 3, it will be non-terminating, non-recurring. For example, it will be, what is that? 1.7320, it's going on. It is non-recurring, not recurring also. It is not recurring also. What is the meaning of recurring? See, in rational number, one number 0.012 bar is means, what is the meaning of bar? Yes, correct, exactly, super, super. So 1, 2 bar. I can write it as a 0.012 bar. How I can able to write? Is anyone, someone is saying exactly correct. 0.01212, but it is non-stop going on. Yes, this is called non-terminating recurring decimal. Non-terminating recurring decimal. But in this, if it is non-recurring, then such a numbers we are calling as irrational number. The combination of rational and irrational only, what is that called? Real numbers. Yes. So natural, whole number, integers, and then rational and irrational, these together is called as a, what is that? Real numbers. You learned it lower classes. X, exact. This only, see that this number line 1, 2, 3, 4 are called as a natural numbers. If I add with 1, 2, 3, 0, it's called a whole numbers. A number without fractions and integers is called a whole numbers. And this is rational numbers, which is in the form of P by Q. It is called a rational numbers, but Q is not equal to 0. Yes. Yes. Very good. Super. So you understood what is a natural number, what is a real whole number, and what is a integers, and what is a rational numbers. And now we are going to learn next one is irrational numbers also you understood. Yes. Yes. Now, yeah. Now irrational numbers. Yes, we learned already. Some examples of irrational numbers will see. Endless non-repeating digits to the right of the decimal point. Root 6 is an irrational number. Yes, obviously all non-perfect square numbers are called as a, what is that? Irrational numbers. 4.6 is not an irrational number. Why? Why? Yeah, because it stops. It's a terminating decimal. So terminating decimals never be an irrational number. Is it root 12 is an irrational number? Yes, because it's 3.4641, it's going on, but non-recurring decimal. But non-recurring decimal. Root 45 and 49, it's a perfect square number. Then it is not a, what is that? Irrational number. It is a rational number because we can write in the form of P by Q. Then it is called a rational number. Yes? Yes. What we are going to learn in this chapter? This is all we learned in our 9th class, 8th class. What is the new thing we are going to learn in this class? We are going to learn the new thing is nothing but that is called, what is that called? Euclid Division Lemma. What is that lemma? Also called as an algorithm. What is the algorithm? The algorithm states that step by step solving the problem. Yes, what is that algorithm? You may learn in your computer. Yes, step by step. Is a connection between now interdisciplinary subject. We can connect this now algorithm to the computer subject also. You know the flowchart of the computers. You learned in your computers flowcharts. Yes, same way we are going to do here step by step solving the problem. How we are going to solve the problem here? We are going to solve the problem by using Euclid division lemma. What is the Euclid division lemma states? A number when we are dividing with another number, then what we'll get? For example, I'm dividing 45 by 8. So what we'll call this is, we learned, yes, 45 by 8, when I'm dividing, what will happen? What is the quotient will be there? 8 5s are 40. Yes, 8 5s are 40. And remainder will be, if you subtract, what will get? 5. So what is the quotient here? 5. And 8 is divisor. What is the remainder? 5 again. And dividend is called as a 45. Yes, that only we are going to learn in this as a Euclid division lemma. So you know in name itself is a division. So we are going to divide two numbers. When we divide a number with another number, exactly we'll get quotient and remainder. So this is introduced by the famous mathematician by Euclid. So we are calling as a Euclid division lemma. Lemma as a sequence where we are solving the step-by-step algorithm that is called a, we are going to learn here. So how we can able to write this Euclid division lemma? See, dividend is equal to, how we can able to verify division rule you learned? Dividend is equal to 45, how I can able to write? Yes, exactly. 8 5s are 8 into 5 plus 5. Yes, 8 into 5 plus 5. Then you will get 45. Yes, this is a called division lemma. This 45, how we can able to write in the variables? We can able to write in the variables. This 45 is nothing but A, and A is called dividend here. 45 is a dividend. And A also we can represent dividend as a small variable as a. And 8 is called B. 8 is called B. That is called divisor. That is called divisor. And Q is called, what is a Q? Yes, Q is quotient. And what you got 5? 5 is called as a remainder. Yes. So this division rule also write in the form of Euclid division lemma. It's nothing but A equal to BQ plus R. Yes, exactly, super. But you should know the condition of this one. What is the condition of here? The condition is nothing but here. It should be 0 less than or equal to R is less than B. Why we have to write the condition? Just now I given one example for you. When we are dividing 45 by 8, yes, you got the quotient as a 5 and remainder also 5. So now, is it possible to proceed next step? You can proceed by using the decimal point. But here, without using the decimal point, we can able to proceed? No. Why? Because this divisor is greater than the remainder. Means remainder is not allowing to divide with divisor. Because remainder is lesser, smaller than the divisor. Yes. So that is a, what is it we have taken as a divisor? Divisor as a B and A as a dividend and Q as a quotient and R as a remainder. So the condition, if sometimes you take one more example, for example 40. When you are dividing 40 divided by 8, how many times you will get 8 table? 8 5s are 40, exactly. Then what is the remainder? The remainder will be 0. Yes, when you subtract this both, yeah. So what you understood? When we are dividing with 8, 40, you got remainder 0. The same 45 you are dividing with 8, you got remainder is 5. So the remainder is either it should be 0, either it should be 0 or it should be less than B. B means, what is the meaning of B? Yes, exactly, super, good. Divisor. It is exactly nothing but divisor. Understood all of you? Yes, I hope you all understood. Again, I will say one more time. Euclid division lemma. Euclid division lemma is nothing but A equal to BQ plus R. But the condition should be 0 less than R is remainder, is less than B is divisor. Yes? Yes, this is very important. What is the use of Euclid division lemma? Why we want to learn this Euclid division lemma? Yes, we have to learn to find the HCF. Ma'am, we know very well already HCF, how to find out HCF. HCF is nothing but highest common factor. We learned in 6th class, ma'am, you can ask question. 100% I know very well, you people know very well to find HCF. But here, 10th class we came. We want to know about what our mathematicians has done. Yes? Yeah, it's a famous mathematician, Euclid is it. So you should know very well about him. That is a very, very important. Yes? So, to know about the Euclid, this one, he has introduced this division lemma. So we'll learn about him. Okay, so how to find out the HCF by using Euclid division lemma? It's very interesting. We are going to see how to find out the using Euclid division algorithm or lemma HCF, finding the HCF. Yes, we'll start. Yes, one second. Yeah, let me use a Euclid division lemma. One example I'll take and I'll explain another example with the help of whiteboard. Okay, shall I start? Yes. I have taken, it is there in your textbook, this example. Just you see the page number 5, you can able to get the idea. Okay, first listen. Before going to the textbook, first we'll do the exercise, we'll see the example. 12576 is a bigger number. We are going to find out these two numbers 4052 and 12576, finding the HCF. What is the HCF? Highest common factor. We used to, this one common factor will be divided with these two numbers. We are going to find out which is a common factor. But here we are going to use Euclid division lemma. What is the Euclid division lemma? You learned just now only. A equal to, what is that? A equal to B Q plus R. Yes, A equal to B Q plus R. Exactly. A equal to B Q plus R. What is the A here? 1, 2, 5, 7, 6. When we are dividing 1, 2, 5, 7, 6 with 4, 0, 5, 2, how many times we can able to divide? We can able to divide 3 times. How many times? 3 times. And what is the remainder will be there? 420. What is the remainder will be there? 420 will be the remainder. Now you have to take 4052 is a new divisor. Now step by step what we learned, we are going to do here by using Euclid Division lemma. We are going to find out the HCF of two numbers. So now 4052, when we are dividing with 420, we'll get 420 into 9 plus 272. Yes, shall we check? Is it true or false? So 40, what is the number? 4052. Please check. 40, all of you, check with me. 4052 dividing with what? 420. Yes, because that is the now reminder we'll get in the first step. So 420 table, how many times? 9 times. So 429s are, can anyone say the answer? 429s are? I'll give you the time. Do one say. Yes. 429s are 3780. 3780. Yes. 3780. So write the 3780 because 36 plus 18, 3780. Now do minus. What will come? 2, 7, yes, 272 is the remainder. So quotient, then 420 into 9 plus 272 is the remainder. That is the step 2. Understood? Step 2. What is the step 3? Now you should divide with 420 and then 272. What we'll get, we'll check. 420 and 272. What will happen? 420 should be inside dividend now and 272 is the remainder divisor. So how many times? Yes, one time. 272 one time. Do it minus, what will happen? 0 minus 2 is 8 and 11 minus 7 is 4 and 3 minus 2 is 1. So now you got 148. How will write now? How will write? So you are going to write with 272 into 1 plus 148. 272 into 1 plus 148 equal to what? 420. Yes? Yes. So 420 is equal to 272 into 9 plus 148. Okay? Understood all of you? Yes. Now how I will write again 272 and 148 you should take. We should take now these two numbers. Each and every step we should take this divisor and this remainder to find next one. Now this will act as a divisor, dividend, and this will act as a divisor. Same way this is as a dividend, this as a divisor for next step. This as a dividend and this as a divisor. Same how many times you can do it, no need to do in rough column also. If you are well perfect in the doing the calculation, you can do without using rough column here. So 148 ones are how much? 148 ones are 144 and remainder will be 124. The same way 148 and the two numbers you have to take and 124 ones are 124, the remainder will be 24. And at the same way 124, how we can write? 24 into 5, 120 plus 4, 124. Then now the next step will come for you. What is the next step? The next step will be Yeah. The next step of this. 1 second, students. I'll erase this one. So now, what is it we got in before step? We got 24 and 4. Yes? Can we check? 24 and 4 is a 1 second. Yes. Now you check. 24 is now, what happened? 24 is a now for us. 24 is a dividend and 4 is a divisor. So now how many times you can able to do? Yeah, we can do it 24. 4 into 6, 24. Remainder what you got? 0. Till you'll get remainder 0, you should do the division algorithm. Understood? So this is called Euclid Division algorithm. I'll take my own example. I will show you how to do that. For example, 455 divided by 42. 455 divided by what number? 42. It is also easy. We have to find out the HCF of these two numbers. HCF of what? Two numbers, 455 and 42. We have to find out. How to find? So step 1, what you have to do? What is the division algorithm states? A equal to, yes, very good, super. A equal to B cube plus R. Now divide 42 table how many times? 455, 10 times. It's 420. Yes. Now minus with 455 and 420. What is the answer you will get? You will get as a 35. Yes. So how you are going to write? First step, 42 into 10 plus 35. 42 into 10 plus 35 is equal to 455. Yes. So step 1, 455 is equal to, I'll erase this one. Yes. Tell me how many times? 42 into 10 plus 35. Yes, you got this one. All of you got? Now what numbers we have to take? Yes, exactly. Super. Someone told 42 and 35. Now do the step. 42 is the dividend and 35 is the divisor. How many times? 35. 35 ones are. Yes, you are perfect in doing the calculation in your mind. You can do it. No problem. 35 ones are 35 plus what is the remainder? 7 is the remainder. Yes, now what you have to do? 35 and 7. So 35 you have to take and 7 table how many times? Exactly, it will divide. Super. So 7 into 5 plus, what is that? Remainder is 0. Now, what is HCF? The HCF is, which is the last divisor, it's called a HCF. Then HCF is equal to 4. What is the meaning of HCF? Highest common factor. Sorry, the HCF is 7. What is the HCF? 7. So highest common factor is 7. Okay. Before sum we got 4. But this sum we got 7. Yes. Clear? All of you clear? Anyone having doubt? I hope you all understood the Euclid division. Shall we do another example? Yes, I can able to hear. So many are asking. Yes, ma'am, we need. Yes. Shall I start doing the another example? I will take, you try. You have to say one by one for me. Yes. Okay. Can anyone say the number? Two numbers? Yes, yes, very good. 350 divided and 350 and which table you want? 350 and 15. Okay, we'll do it with 15. 15. Okay, shall we start? So now 350, 15 table, how many times? Can anyone say the 350, 15 tables? 15, 15 into 15 tens are 150, 15 20s are 300, 15 13s are 345. Yes? Plus, what is the remainder? 350 minus 345. 5 is the remainder. Now you should take which number? 15 and 5. So what will happen now? 15 and 5 if you take, how many times? 5 into 3. Remainder is there? No, remainder is 0. So what is the HCF? The HCF is 5. All of you understood? The HCF is what here? 5. Can anyone understood? Can anyone having doubt? Yes, I hope you all understood. Very good, students. Thank you, students. So we can move on the exercise 1.1. You can complete exercise 1.1 in your classroom. Thank you, students. Thank you very much. Thank you.